Hello, we're back with another video. And today I want to talk about this. You're probably wondering, well, what the heck is this? This is what I like to call number conversions. Oh boy. When in the world of IT, you'll be doing quite a bit of this. It's commonplace to be converting decimals to binary, binary to hexadecimals, and etc. And let me tell you, it can be quite confusing and frustrating. But what if I told you it doesn't have to be that way? So this chart will help guide us through the conversion process. Let's start off with an easy one. Let's start off with converting decimal to binary. And let's convert, let's say, 136 into a binary value. Now, in the world of computers, binary is their language. They run on ones and zeros. And one thing to remember is a value of 1 equals on, and a value of 0 equals off. So where exactly do we start if we want to convert this into a binary value? Well, look at our decimal row. If the decimal row number is less than the number that we want to convert, and if we subtract them, it'll turn out to be a positive number, then it'll be a 1 value underneath this row right here. Likewise, if it's a number that's greater than the number that we're trying to convert and we subtract them and it turns out to be a negative number, then it'll be a 0 value in this row. So let's do our calculations. So 136 minus 128 comes out to be 8. So since our answer turned out to be a positive number, in this row, we put a 1. Moving on to the next value in the decimal place is 64. Now I can guarantee you right now that's going to end up to be a negative number if we take 8 minus 64. So because of that, it's a 0 value. And it's the same case with 32 and 16. They will both end up being a negative number. So those two are also zeros. And 8 minus 8 comes out to be 0, which is a positive number, so we put a 1 there. And 4, 2, and 1 are all going to be zeros because since we now have 0, nothing can be subtracted from it without being a negative number. So all zeros. And there you go. That is our answer. 136 converted into a binary number is 10001000. We can also check our answer. So to do that, we would take the first number that we subtracted from the number that we were converting from the decimal row, which is 128. So 128, and then we would add it to the number, the first positive number that it turned out to be, which is 8. So 28 plus 8, and that comes out to be 136. So yes, our answer is correct. All right, let's do a switcheroo here. Let's do binary to decimal. So it's honestly not that much harder. It's basically the exact same thing, except we're doing things in reversed. So let's convert 10111010 into a decimal. So when it comes to binary to decimal, remember 1 equals on and 0 equals off. So if it's an on value, then that means that we can use the number. But if it's a 0, we can't use it. So every single 1 value, we look up on the chart and look at the corresponding decimal number that's under and add them together. So since 128, 32, 16, 8, and 2 are on, we would add all those together. So let's do 128 plus 32 plus 16 plus 8 and plus 2. And that comes out to be 186. So to reiterate, when converting binary to decimal, if bit is off, do not add. If bit is on, add. All right, let's kick things up a notch. Let's do binary to hex. So let's look at our hexadecimal row, which is 8, 4, 2, and 1, and then it repeats on the other side. You're probably wondering what this line is for. I will get into that. So the binary value that we want to convert is 1, 0, 0, 1, and 0, 1, 1, 0. And guess what? It's the exact same principle as converting binary to decimal. We look at the placement of the ones, and if it's on, we add them together, and if it's off, we don't. So looking at the placements on this area, the 8 and the 1 are on, so we would add 8 and 1 together, which turns out to be 9. And on this side, 4 and 2 are on, so 4 plus 2 equals 6. And then we don't add these two together, but instead we just put them together. So our answer turns out to be 96. Now here's something to keep in mind with hexadecimal values. They work a little different than decimal values. So they both start at 0, but unlike decimal values where after 9 it goes 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, after 9 in hexadecimal it goes A, B, C, D, and F. So let's do another one just to show you what I mean. So let's do 1, 1, 1, 1, and then 1, 0, 0, 1. So since all 4 of these bits are on, we would add 8, 4, 2, and 1, and that turns out to be 15. And then the 8 and the 1 bits are on this side, so add them together, they equal 9. And since we're converting to a hexadecimal value, we can't use the number 15. Instead, we would use F and then 9. Simple as that. All right, let's move on to decimal to hexadecimal. So this is where things get a little trickier. So you can convert decimal values to hexadecimal values. There's just a little more work involved in it. So first you have to convert it from decimal to binary and then binary to hexadecimal. So the value that we want to convert is 221. Well, let's do the exact same thing that we did for converting it to binary. Subtract 128 from it. That comes out to 93, which is a positive number, so that's a 1. And then 93 minus 64 comes out to 29. That's a positive number as well. That's another 1. We can't subtract 32 because that would come out as a negative number, so that's a 0. We can subtract 16, and that comes out to 13. That's a positive number, 1. We can subtract 8, which comes out to 5. That's positive. That's another 1. We can subtract 4, which comes out to 1. That's positive. We can't do 2, because otherwise that would be a negative number. That's a 0. And finally, we can subtract 1. That's a positive number. There we are. So 221 in binary comes out to 1101, 1101. Now let's convert that into a hexadecimal value. The 8, 4, and 1 bits are on, so add them together. It comes out to 13. And likewise on the other side, the exact same bits are on, so that's 13 as well. And you put those numbers together. Because we're dealing with hexadecimal values, we can't use 10 through 15. So we would use D, D. And there's our answer. All right, let's end things off with hexadecimal to decimal. It's the exact same process, except reversed. So the value that we want to convert to decimal is F3. That's an easy one. So for starters, we would separate those values. So F in hexadecimal is actually 15, and then 3 is obviously 3. So just like we did with decimal to bi, we would do the exact same thing except we'd use the hexadecimal row. So going through 8, 4, 2, and 1, all four of those can be subtracted from 15 and still end up being a positive number. So 15 minus 8 is 7. That's positive. That would be a 1. 7 minus 4 is 3. That's positive. That's another 1. 3 minus 2 is 1. That's another 1. And finally, 1 minus 1 is 0. That's positive 1. And then we would do the exact same thing for 3. 8 and 4 cannot be subtracted from 3 without being a negative number, so those two will be a 0. 2 can be subtracted from 3 and still get a positive number, so that's a 1. And 3 minus 2 is 1. 1 minus 1 is 0. You get it. And now it's the exact same process as converting binary to decimal. So every single one is a bit turned on, so we would add 128, 64, 32, 16, 2, and 1. So 128 plus 64 plus 32 plus 16 plus 2 plus 1 comes out to 243. So for our final answer, F3 converted into decimal is 243. And there you have it. Before I was shown how to do it this way, number conversions was like hell on earth. But now that I know how to do it this way, it's like a walk in the park. And I hope after watching this video, it's a walk in the park for you as well. So, thank you for watching, and I'll see you all next time.